Alright, this video is about brief solutions and hints for the current assignment, assignment 10. And let's look at the first problem over here. We are trying to determine whether the following differential equations are linear and separable. So look at the first one. We have to rewrite it, and remember this is the easier way to see whether it's separable or linear. If we rewrite it, we have ay squared. Remember, we can simply suppress t in the dependent variable, then we have something like this, and by and plus c. So because we have this term over here, so it's nonlinear, and this function over here is a function y only, so this is something like 1 times ay squared plus by plus c. So this one over here is nonlinear and separable. Separable because this is a function of t and this is a function of y only. Alright, let's look at the second problem over here. The second problem, we do the same thing, but now we have ay prime is equal to negative by plus c. Now this is linear over here, and we don't have any nonlinear form. So this one over here is linear, and it's also separable. It's also separable because we can see over here is a function of t, and over here is a function of y. And third problem, over here we have y prime is equal to ty and plus t squared. And we see there is a common factor, and that's t and y plus t. But we cannot factor this one anymore. We cannot write this function into a product of function t and a function of y. So this one is not separable. So say not separable. But it is linear because it's linear about y. This term doesn't matter because it's a function of independent variable t. So this one is not separable, but it's linear. Okay. And by the same reason, the fourth one over here is separable, nonlinear. Separable and nonlinear. Okay. Let's look at the second group of problems over here. So this is the first group over here, and then we have the second group. All these equations are separable, so we just need to integrate, and this one over here is y. Now we divide both sides. This is something we have, dy, and it's equal to x and dx. So we integrate, and this is y to the negative 1/2 dy, and it's equal to x dx, etc. And I can do that. Second problem, you can see we have 1 over y squared dy is equal to negative 0.2, and then we have y to the negative 2 dy, and it's equal to over here lost dx, and then we have negative 0.2 dx. Okay. You may ask, why don't you divide negative 0.2 to the left hand side as well? This way is simply easier. Okay. So this is first one, and this is second one, and third one over here we have y prime is equal to y squared minus 1x. This is very similar to the problem we have in the lecture notes, because now you have 1 over y squared minus 1 dx dy over here is equal to x dx, and integrate both sides. But remember, you need to use integration by partial fraction decomposition. Decompose this one to a over here y minus 1 plus b over y plus 1. And you can see this is going to be equal to y squared minus 1, and then you have ay plus 1 and plus by minus 1. We compare both numerators and denominators. Denominators are common, so we rewrite this one in the following way. This is y squared minus 1, and we have a plus b. Collecting these terms, and then constant term, we have a minus b. And if you look at it, this is 1. That means we have really 1 plus 0y. And we compare these two numerators, we have a pair of equation that's a plus y must be equal to 0. The coefficients should match, and a minus b should be equal to 1. And solving this one over here, we will have the decomposition, and then we integrate, and you can actually see these things in the textbook. Okay, and for the last group of problems, they are rather standard, so I'm going to just look at say problem 3 over here, what we have. So we have the characteristic equation over here. If we write it down, it's going to be r squared plus 2r and plus 5 is equal to 0. And we can simply use the quadratic solution formula, and r12 is -2 plus minus root over here. We have 4 minus 20 over here, and then divided by 2, and we have -2 plus minus, over here we have I4 over 2, and then we have 2 roots, and it's -1 plus minus I2. Okay, so according to what we have, the solutions should be, we have 2 solutions, y1 of x. Using this one, we have e to the -x cosine 2x, and y2 of x, we have e to the -x and sine 2x. Remember where these things are from. -1 is the real part, and here 2 comes from over here. And your general solution, what we have over here, y of x, is simply going to be e to the -x and c1 cosine 2x plus c2 sine x, right? And last problem over here, in 5 over here, we have r squared and plus 2r is equal to 0. So we factor, and then we have these 2 roots. r1 is equal to 0, and r2 is equal to -2. So we have 2 solutions over here. One is e to the 0x, which is simply 1, and the other one, while y2 of x is equal to e to the -2x. So the general solution, y of x, is equal to c1 plus c2 and e to the -2x. Okay. Now, the last problem over here, we have initial value problems, and we just do the similar kind of thing. Remember, we determine c1 and c2 by plugging in the initial values, and then we should have those problems solved. Okay, I think time is almost up. Let me just stop over here.